The Joule, symbol J, is a derived unit of energy in the International System of Units. It is equal to the energy transferred to an object when a force of 1 Newton acts on that object in the direction of its motion through a distance of 1 meter. It is also the energy dissipated as heat when an electric current of 1 ampere passes through a resistance of 1 ohm for 1 second. It is named after the English physicist James Prescott Joule, in terms firstly of base SI units and then in terms of other SI units, where kilogram is the kilogram, m is the meter, s is the second, n is the newton, par is the pascal, w is the watt, c is the coulomb, and v is the volt. 1 joule can also be defined as the work required to move an electric charge of 1 coulomb through an electrical potential difference of 1 volt, or 1 coulomb-volt. This relationship can be used to define the volt. The work required to produce 1 watt of power for 1 second, or 1 watt-second. This relationship can be used to define the watt usage. This SI unit is named after James Prescott Joule. As with every International System of Units unit named for a person, the first letter of its symbol is uppercase. However, when an SI unit is spelled out in English, it should always begin with a lowercase letter, except in a situation where any word in that position would be capitalized, such as at the beginning of a sentence or in material using title case. Note that degree Celsius conforms to this rule because the d is lowercase, based on the International System of Units, section 5.2. Confusion with Newton meter. In angular mechanics, torque is analogous to the linear Newtonian mechanics parameter of force, moment of inertia to mass, and angle to distance. Energy is the same in both systems. Thus, although the joule has the same dimensions as the Newton meter, these units are not interchangeable. The CGPM has given the unit of energy the name joule, but has not given the unit of torque any special name. Hence the unit of torque is known as the Newton meter, a compound name derived from its constituent parts. Torque and energy are related to each other using the equation where E is the energy, tau is the torque, and theta is the angle moved. Since radians are dimensionless, it follows that torque and energy have the same dimensions. The use of Newton meters for torque and joules for energy is useful in helping avoid misunderstandings and miscommunications. An additional solution is to realize that joules are scalars. They are the dot products of a vector force and a vector displacement, whereas torque is a vector. Torque is the cross product of a distance vector and a force vector. Drawing a traditional vector arrow over Newton meter in a torque resolves the ambiguity. Practical examples. 1 joule in everyday life represents approximately the energy required to lift a small apple vertically through 1 meter of air. The energy released when that same apple falls 1 meter to the ground. The energy required to accelerate a 1 kilogram mass at 1 meter s-2 through a 1 meter distance in space. The heat required to raise the temperature of 1 gram of water by 0.24 K. The typical energy released is heat by a person at rest every 1/60th second. The kinetic energy of a 50 kilograms human moving very slowly. The kinetic energy of a 56 grams tennis ball moving at 6 meters per second. The kinetic energy of an object with mass 1 kilogram moving at square root 1.4 meters per second. The amount of electricity required to light a 1 watt LED for 1 s. Since the joule is also a watt-second and the common unit for electricity sales to homes is the kWh, a kWh is thus 1000 watt times 3600 seconds equals 3.6 megajoules. Multiples. For additional examples, see Orders of magnitude zeptojoule. The zeptojoule is equal to 1/60th of 1 joule. 160 zeptojoules is equivalent to 1 electron volt. Nanojoule. The nanojoule is equal to 1/1000th of 1 joule. 1 nanojoule is about 1/160th of the kinetic energy of a flying mosquito. Microjoule. The microjoule is equal to 1/1,000,000th of 1 joule. The Large Hadron Collider is expected to produce collisions on the order of 1 microjoule per particle. Millijoule. The millijoule is equal to 1,000th of a joule. Kilojoule. The kilojoule is equal to 1,000 joules. Nutritional food labels in certain countries express energy in kilojoules. 1 square meter of the Earth receives about 1.4 kilojoules of solar radiation every second in full daylight. Megajoule. The megajoule is equal to 1 million joules, or approximately the kinetic energy of a 1 megagram vehicle moving at 160 kilometers per hour. 1 kilowatt-hour is 3.6 megajoules. Since 1 watt times 1 second equals 1 joule, 1000 watts times 3600 seconds equal 3.6 megajoules. Gigajoule. The gigajoule is equal to 1 billion joules. 6 gigajoules is about the amount of potential chemical energy in 160 olive oil when combusted. Terajoule. The terajoule is equal to 1 trillion joules. About 63 terajoules of energy was released by the atomic bomb that exploded over Hiroshima. The International Space Station, with a mass of approximately 450 megagrams and orbital velocity of 7.7 kilometers per second, has a kinetic energy of roughly 13 terajoules. Petajoule. The petajoule is equal to 1 quadrillion joules. 210 petajoules is equivalent to about 50 megatons of TNT. This is the amount of energy released by the Tsar Bomba, the largest man-made nuclear explosion ever. Exajoule. The exajoule is equal to 1 quintillion joules. The 2011 Tohoku earthquake and tsunami in Japan had 1.41 EJ of energy according to its 9.0 on the moment magnitude scale. Energy in the United States used per year is roughly 94 EJ. Zetajoule. The zetajoule is equal to 1 sextillion joules. Annual global energy consumption is approximately 0.5 ZJ. Yatajoule. The yatajoule is equal to 1 septillion joules. This is approximately the amount of energy required to heat the entire volume of water on Earth by 1 degree Celsius. The thermal output of the Sun is approximately 400 Wj per second. Conversions. 1 joule is equal to 700010000000000000000 times 107 erg. 7000100000014880946.2415097 times 1018 electron volts. 6999999976000000000 cal. 69999999760000000 2.390 times 10⁻⁴ kilocalories. 70010003038230289.4782 times 10⁻⁴ BTU. 69997360000000000 feet pound. 6999987206092231733.7 feet PDL. 69932777800000000 2.7778 times 10⁻⁷ kilowatt-hour. 69962777800000000 2.7778 times 10⁻⁴ watt-hour. 69999996690000000 9.8692 times 10⁻3 LATM. 698611126500011.1265 times 10⁻15 gram. 700100000000000000000 times 10⁻44 Fo. Units defined exactly in terms of the joule include 1 thermochemical calorie equals 4.184 J. 1 international table calorie equals 4.1868 J. 1 watt-hour equals 3600 J. 1 kilowatt-hour equals 700636000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 equals 70010001000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000004.184 gigajoules.